Hello, it's Dr. AJ Kumar. Alright, it's the daytime now, so I'm gonna, and I have enough sleep, and so my batteries are fully charged, and what I'm gonna do is go and try to fix the internals of WFC, because that's sort of a thing that needs to be done. So let's just look. So it needs. Okay, first of all, the string parser needs to be better. Okay, and what do I mean by this? It's just disgusting right now. So let's do I have a session for WFC? No, I do not. God damn it. Okay. So let's, first of all, the internals of it need to be fixed. So let's walk through how it works starting from the bottom. So what is a word? A word is the smallest unit in a reduced sum. And for instance, 1 plus A plus AB, the words are 1, A, and AB respectively, which are represented as the set's empty set, A, and A comma B respectively. A word is a tagged tuple W set of atoms. The empty set equals 1. In WF algebra, anything times itself equals itself, right? Therefore, we don't need to keep track of exponents, right? That's why the set representation makes sense. With a word, multiplication is implied. Okay, and so at WF char, I think instead this needs to be changed. Okay, so let me check the git status. Git diff. Alright. Type map01. Okay. WF char okay, instead of an atom, it will be C any. Okay? I think this is the best I can do. Okay. Okay. Let's start with one. So the base. Okay. And then is one, that'll be our next thing. is valid word. Contains only valid, contains only chars. Is valid word, and also char, then is valid char, C true, false. There we go. Okay. From list. Given a list of characters, what should we call let's call the thing inside a character, let's call this a glyph, and let's make it be an atom, a string, or a binary. Okay. Is glyph x, is glyph is x or else, is string x or else, it's binary. It's is list, not is string. Is binary. Okay, is one, is valid word, okay, okay. From list, a list of glyphs. Given a list of glyphs, okay, chars is equal to C glyph glyph glyphs chars okay, let's Okay, and then from list, next will be to list. I'm organizing these logically because then it's actually easier to read. I thought that it would be easier to read code. It's easier when you're looking up documentation, but it's easier to read code that's sorted sort of in a more logical way. Okay, to list. Am I recording? Let me make sure. Yeah, looks good. Okay. To list, word, and we don't want characters, we want a list of glyphs. Why do we need to wrap it in that C thing? We'll think about that. You know what, I like tagging things for what they are. The character is its whole. Okay. Unchar equals fun C glyph. And this can be one-lined. Okay. Chars is equal to sets to list set. Glyphs is equal to list map chars unchar glyphs chars, and we will return list sort glyphs. Okay. Oh, that's annoying. Because it'll store atoms. Yeah, we'll deal with that. I'll live. Okay, what's the next one? This is sort of our fundamental operation, which is multiplication of the characters save for removing one. Ooh. No, so this is silly because now yeah, no, we want to have one single type. No, we want a single type of glyph. It's going to be a string, okay? So that's just simple. That's disappointing. I would love to use atoms, but we can't. Who is texting me? Nope. Do not disturb. I would love to have atoms. That's because I mean it's just natural, but can't have users inputting atoms. Ugh. This is awful. All right. Okay. Isglyph is islist. Should we do binaries instead of lists? Because binaries are going to have faster matching. Does that matter? I don't think that matters. Let's do binary. Because all that matters here is matching, and then it'll be a little bit faster. Okay. I'll live. Okay, and we'll have to go fix this documentation. Okay. So these are in alphabetical order, that's fine. I hate that so much. It was very nice the way that it worked before. Okay, times. Okay, we'll live with that. Evaluate. Word. Map01 is a map from a glyph to hope. Okay, that'll have to be it. Folder fun char. Okay, pretty format a word. Right. It'll sort them. That's right. Okay. Okay. This can be okay, that will work. This should work. Let's just use a list just to be safe. Yeah, you put a space before, so I'm just trying to remember. Yeah, okay, yeah, this is fine. And then let's just list reverse cum. Binary glyph, okay, rest cum, new cum, okay, wait, word, or, god damn it, arg equals io_lib format space %s glyph. Arg cum new cum I see how that was working. This is fine, I think. This should work. This is so unfortunate that I have to do this binary nonsense. WF char If you wish to use PF1, the binary must be string formatable. Let's look at the sentence. Okay. And that should be it as far as what we need to do. But let's check. This should be simple because I don't think this assumes anything about the data structure of the sentence. But what we will need to do is when we do the porcelain functions, we're going to have to coerce everything over to binary. Okay, so let's just check. Okay. Map01, not an atom, unfortunately. Okay. Let's make this bigger. Okay. First thing we're going to construct is 0. So 0 is the most basic word. Or is the most basic sentence. Okay. The next sentence the next most basic thing is 0. Okay, the next most basic thing is valid sentence. Okay. That none of which are the 0 word. I don't think we need that. Because if you watch the podcast, I did this stupid thing where I had 0 be a word and so that created some technical debt or some waterbed problems. Is valid sentence. Okay, is valid sentence. Let's, we can, yeah, here's what we can do. It's just this. Valid words. That's it. Okay, tagged. Set contains only valid words. There, that's it. Okay, what's the next? this can get deleted. I'm just going to reorganize these. Fact, export. Zero is zero is valid sentence. A sentence is sort of our all-seeing, all-knowing type. Okay. The next is plus. Okay, let me just look. Yeah, plus 2 sentences. This is sort of our next thing. Plus the symmetric difference, right? Set symdiff. This doesn't need to be exported. There we go. We're not going to use this sum thing. That's a porcelain function. It doesn't belong here. These are plumbing functions. Okay, plus, converting from a list. Yeah, and to a list. From a list and to a list. Okay. Okay, I can't stop because I've got too much in my head. Okay, from a list. From a list of words is valid sentence. Okay. And to a list. Yeah, and then this should just spit up. These are the most basic things. To a list. To a list of words, and then we also want to sort them. Okay, and then list, sort, there we go. We might want to use an ORD set rather, but this is fine. It annoys me when they're not. When the words show up out of order. Okay. To a list plus and then times. Okay, we need times. And we also need eval. Okay. Okay, let's look at times. I think times will work exactly the same way that we expect it to. Times. Okay, we don't want these. We don't want this porcelain function. We don't want these porcelain functions in here. This is plumbing. Okay, these porcelain functions do not belong in here. Okay, evaluate. No. Times. Here we are. Okay. Times is just an alias for sentence times sentence. Okay. And then these internal functions, I like to just put them right there. Okay. Okay. Right here. So, okay. Time, these are just sets. I think you can just how does this work? I think this isn't needed now. Okay. How does really sentence times sentence work? Okay. Okay. So it folds over the list of words in the left sentence. Right, it applies the distributive property. Okay, so this is, let's just do, this is A plus B times C plus D. And we only need these two validations here, I think. But let's walk through the logic of how this works. Okay, word times sentence. Yeah, if we just have 0, okay, this 0 thing I think is an artifact from when I had dumbass code. So I think we can just delete all of this, and if it doesn't work, we can go back and look at the old commit. But I think this is what we need. Okay. i.e. E plus B times C plus D, that word times sentence operation is done in WXS2. Okay. Sentence times sentence. Okay, and now let's go to word times sentence. Okay. Word times sentence. This is for A times C plus D. Split the right sentence into split this into AC plus AD. Each of those operations are done in word times word. Okay, word times word. Okay. Okay, and since this is this okay, we don't need these internal accumulators. Those just slow. Okay, that just slows shit down. And then where is word times word? Here we are. Okay, that's already done down there. Sentence. Yeah, word times word. It's important to note that this returns a sentence, and so I am going to copy that spec because that's important. And you know what, I will do these. This goes with word times word. Note. Word times sentence. Okay. Boy. Okay, and I do need to keep track of these versions. Okay, so we did plus and we did times. Let's do eval. Eval in pretty format, and I think that should be it. And then these other ones we don't need. These are the low-level, sort of minimal definitions. Okay. Times word times sentence multiply two sentences. Okay. This bothers me. Where's toList? Okay, let me sort these in this sort of more logical order. Okay, one is valid word. From list and to list. Times eval and pretty format. Okay. These internal modules are just like the minimal definitions. Okay. And then do we have any other junk? No, I think this is it. Okay, this one, I like WFC word. Okay, this, okay, let's go look. Eval and pretty format. Okay. Okay, I'm going to zoom out so I can see the whole thing. Okay, we have 0 is valid sentence, from list, to list, plus times, yeah, okay. And then the next one will have to be eval. And you know what, since this is sort of a nice little chain of logic, I'm going to move this down to its own private internal section. Okay. We don't need this really sentence times sentence thing. Okay, this XOR function, where is this used? Really, okay, well, we'll have to see how this eval function works. Okay, eval. Okay, evaluate a sentence against a map. And let's find really eval. I don't think we need this really eval thing. Because this was, I think, a holdover from when I had the dumbass representation before. Okay. I think we can just, yeah, okay. Okay, yeah. In fact, I can make this even more tight. Okay, I can just move this in here. sets fold. Don't need this. And instead of elixir, we can just do XOR equals fun. We can just inline it. And let's move this elixir. God damn it, where is elixir? Okay, we don't want this from Word or from WFHR. Fuck that. Don't need this. Don't need this. Okay, but we do need pretty format. Uh-oh. What am I editing? Okay. I just have a bunch of blank space. That's the problem. This elixir function can go away. Okay. And then the pretty format. If sentence is 0 plus word 1, word 2, word 3. Got it. Okay, that's what it will look like. Formats as, okay. Pretty format. Sentence. Is a valid sentence. Okay, I don't need to check if it's a valid sentence. Okay, we don't need... Okay, I think we can just do this. Okay, stirs equals this. Okay, PF words. Pretty format the words. Okay. You know what? This is more obviously correct. I like this approach better with the I/O list. That's more obviously correct. And then this other thing over here that I was doing with the reversing the list, I don't like this as much. This is more obviously correct. Okay. This is more obviously correct. It might be less efficient, but it is more obviously correct. Okay. There we go. Okay. I like this. Got the internals of WFC. Okay, and it's definitely broken now. Okay. Oh boy. All right, I need a I need to take a break because this redoing the porcelain is going to be a menace. Okay, so I don't know, how long has this video been going? Is a good break time? Okay, about an hour. I've been working for about an hour, so yeah, that makes sense. I need a break. So let me open up the Scratch. Okay. 2 done. To do. Okay, so what did we do? We gutted the internals of WFC to longer store variables as atoms, uses binaries instead. To do, redo the porcelain. Needs to have arbitrary truth tables. Needs to be able to pretty print a truth table. Okay, a truth table. I'm deciding. Okay, let's define a truth table as a function that takes zeros or ones and outputs either a 0 or a 1. That is what a truth table is. Okay, and then a sentence function Gah! Okay, a sentence function. A sentence function is some some trickery over the truth table that allows, okay, suffix tt, okay? A sentence function is some trickery over the truth table that allows inputting sentences. A sentence macro is a sentence function is a function that takes a list of says and does some fold or something over them, mostly for syntax convenience. Example would be +001 being something like and A, B, C. Okay. Needs to have arbitrary truth tables. Sentence function is some trickery over the truth table. Suffix sentence macro. And we also need to go through and add version headers. Okay. Because I'm getting to the point where I need to start using the real features of ZX. And we're also going to need, I think we're going to need to split. We're probably going to need to split. See, I think maybe let's put this in a maybe. Split WFC. Need to split the Lisp server into its own thing. And that way it can have state. Do I want it to have state? No, I think the Lisp server is better. And that way it can have variables. Or patterns, rather. That way it can have patterns, needs state, that way it can have patterns. And the web interface can remember your history by storing some session. Okay. And that'll give me a little bit of experience with cookies. That's a good idea. All right. That's all for now. I need a break. All right. Okay. All right. That's all I have. Thank you for listening. Goodbye.